It's easy to make audio measurements on smart glasses using SoundCheck. Let me show you how. As you probably know, most smart glasses and AR/VR headsets contain small speakers, usually embedded in the arms close to the ears. They also have microphones hidden in the frames. This means we can make audio measurements on smart glasses pretty much the same way we do with a Bluetooth headset. Let's start with our setup. You need a head and torso simulator, or at least a test head. This lets you position the glasses as they would be worn in real life and record the sound at the ears. If you want to measure the microphone as well as the speakers, you'll need one that includes a mouth. Alongside this, you'll use an AmpConnect 621 audio interface. This transmits the signal from the microphones into the laptop, which is running SoundCheck. It also provides amplifier output to power the hat's mouth. We're also going to need a SoundConnect 2 microphone power supply because I'm using an older hat that needs 200-volt polarization power. If you have a newer version, you can power it directly from the 621. And I'm going to use a BQC Bluetooth interface to communicate with the smart glasses. We'll use two basic test sequences that you can download from our website. Let's run the sequence and take a look at the results. Then I'll explain what we're doing. First, the sequence is prompting me to pair my device. I'll put it in pairing mode and say yes. We can see in the list here, now it's telling me to put the smart glasses on the head and torso simulator. Let's do that. And we're ready to make our measurement, so I'll hit enter to continue. That was the test signal, a sweep, which is a special type of step sine wave. Now we can see our results. On the top graphs, we have the left and right frequency response. You can see they are pretty well matched. The response is rolling off quite a bit in the low end, so anything below about 500 Hertz in all these measurements will be very noisy. Here we have the total harmonic distortion of both the left and right speakers. And down here at the bottom, we have the left and right balance, which you can see is pretty flat up to about 8 kilohertz. Above this, we see some discrepancy as the responses of both ears have more peaks and dips. This is very sensitive to positioning, so it's important to make sure the glasses are correctly positioned on the head. It's also good to make multiple measurements, completely removing and replacing the glasses to see how the balance changes. Now let's take a look at the sequence and I'll show you what we did. We start with our stimulus step, which is configured to sweep from 20 kilohertz to 100 hertz. Then we have some message steps. That's where it was prompting us if we wanted to pair the glasses using Bluetooth and confirm once it was paired and placed on hats. Then you could see we play the stimulus and record the response. Now we have some post-processing going on. Because the Bluetooth output and AmpConnect input don't use the same master clock for sampling, we have to resample and frequency shift so that the stimulus and response are aligned for analysis. I'm not sure if you heard the short tone at the beginning of the test signal. That was a trigger tone that lets SoundCheck precisely align the waveforms by playing a signal within the passband of our device. Once we've done this, we can run our harmonic track analysis to calculate frequency response and distortion, and also another post-processing step to calculate the left-right balance. Finally, we have a display step that shows all these results on screen. These smart glasses also feature a microphone for making calls and recording, so let's now measure that. We'll use exactly the same setup with a different sequence. This time we're going to play the stimulus from the mouth and capture the recording using the microphone. Let's run the test. We're pairing it again and we're switching the Bluetooth profile to HFP, hands-free profile, as this is what you would typically use for making calls. We made the speaker measurement using the A2DP profile, as that's what you would typically use for listening to music. Now it's going to play the test signal and output the frequency response. And we could see it's pretty uniform from about 300 Hertz to about 7K or so. Then it rolls off. Let's look at the sequence to see what we did here. Here we have our stimulus sweeping from 8 kHz down to 100 Hz, which aligns with our HFP Bluetooth profile that we're using for this measurement. We have our message steps, same as before, to connect via Bluetooth. And here we have our stimulus and acquisition step, which you can see we're playing out the mouth simulator. And after we've done our frequency shift and resampling, we can calculate the frequency response of the microphone and display that on the graph. So as you can see, testing smart glasses using SoundCheck is quick and easy. Just a couple of minutes to run the tests. And these are pretty basic tests. If you want more extensive measurements, you can simply modify the sequence to add other results that you want. With a little extra equipment, you could also make measurements with background noise or make audio leakage measurements. You can download these test sequences for free on our website, and they'll work with any Bluetooth device with a speaker and microphone. So not just smart glasses, but headsets, VR and AR goggles, etc. Check it out and call us if you have any questions.